So you can very well put this in Desmos. They've already given us the parent function, right? So we've talked about the parent function over and over and over. F of x equals what? X squared. And that is what all of our parabolas are based off of. So what did you notice when you put in 2 times the quantity of x minus 3 squared plus 1? What did you notice that it looked like? It was, okay, it was skinny. It was narrower. What else did you notice? It went to the right. How many?
3.
1, 2, 3. So I'm going to zoom in here so I can draw it like you did. And it went up by 1 and it was narrower. So it went over 3 to the right. It went up 1 and then it was narrower. Like this. Yes?
Yes.
So what caused all of those things to happen? You said it got narrower. You said that it went to the right 3 and it went up 1. So where do you see in these numbers here, what caused each of those things to happen? Noah, give me one. The 2 made the graph what?
The graph compress horizontally.
Not horizontally. Horizontal is going to be in the parentheses, right? We talked about the fly machine. So vertically, what did it do? It was a vertical what? Stretch. Very nice. And that was what made it skinny or narrow. What did 3 do? It moved it which way? To the right. But it's a minus. Insiders lie. Okay, so the right 3. Remember, if it is in the parentheses, okay, this is a horizontal shift. We're going to talk about that some today. What did the 1 do?
It made it go up 1.
It made it go up 1, right? If it's not inside the parentheses, it is a vertical. So we've graphed it, okay? What did we say the vertex was? Positive 3, positive 1. And where do you see those numbers in our equation? They're the ones being what? Right and up. Okay, they're ones being added or subtracted. So those are actually our vertex, okay? So we call it the HK, right? The vertex is the HK. H standing for horizontal. K is going to be your up, down. So where do we see it? That it's going to be our numbers that are added or subtracted. Okay, not multiplied. The multiply, remember last week we talked about, makes it skinnier or wider. Okay? All right, so that equation is actually in what we call vertex form because it tells us specifically what the vertex is. So today we're going to look at that, and then we're also going to talk about converting between vertex and standard form. So we're going to complete this box. We're going to use our definition to help us. So vertex form, I want you to notice HK. HK is our vertex. Okay, do remember that insiders lie, like you said it a minute ago. So if it's a minus H, which is really a positive, if it's a positive H, it's really going to the left. All right, and then our A is going to determine if we open up, which is a positive, meaning that we have a min value, a min vertex, or if it opens down, which means that A is negative, and we have a max vertex. Okay, it will also determine our width, but that is not too big a deal today. Okay, really we're talking about mins and maxes in the vertex. All right, so let's look at these examples. This first one, what is our vertex? What is our H? Remember, H is horizontal, and our K and insiders lie. Positive 5, positive 2, insiders lie. So if it's a negative, we're going to write it as a positive because that really means to the right. And then, is it a min or a max? Look at your A. Is it a positive or a negative? Positive. So that just means it's normal. So it's going to open up. So we have a min or a max. We have a min. What about R of x? What's the vertex going to be there? negative 6, negative 4.
That's a max.
And it's going to be a max. Just as a refresher, it's been a while since we did it. The min and the max value will be the k. So we could say the min value, and that's where we looked at with the range the other day, right? 2 and negative 4. That would be part of your range. If you remember, we talked about that Thursday, I think it was. I apologize. It is a min. I was looking at the one below it. So it is a min, but it's still going to be negative 4. So what about this one, this last one? Positive 10, 0, good. Min or max? That one is a max. And what's the max value? 0. So when we write in vertex form, we can convert it back to standard form. Standard form is that ax squared plus bx plus c that we used so much in the last unit. Okay? But the beauty of vertex form is that we can, in fact, find the vertex. So we're going to actually look at two different things on this. What is the vertex in this first equation? Positive 4, positive 5. Is it going to be a min or a max? It is going to be a minimum. Okay? So the nice thing about looking at that, and you don't have to draw this if you don't want, I just want you to be aware, you don't actually have to graph it in the calculator, computer, unless you just really wanted to. Right? The nice thing is that you can very easily see, okay, positive 4, positive 5, it's going to open up, right? So it kind of gives you an idea. Would we have any roots here? Just from looking at that sketch, would we have any roots? No. Okay. If you want to put it in the computer, definitely to just see what it looks like visually, you can absolutely do that. But it also wants us to change it to standard form. So this is where what we did in the last unit is going to come into play. If you are squaring something, y'all told me earlier that meant we had to write it twice. So if we're going to expand this and change it back, essentially what we're going to do, we're going to say x minus 4 times x minus 4, and then we have plus 5. And we're going to need to use all of the things that we've used in the past to go ahead and expand this. So we need to use FOIL or box. I believe most of us in this class liked FOIL. Right, so we've got x times x is x squared. X times negative 4 is negative 4x. We have negative 4x again, and a negative times a negative is a positive 16. Oh, we did the box? Okay, I'll do the box on the next one. And then we still have this plus 5. We're not quite done because we can collect like terms, okay? We actually have two sets of like terms. So we have x squared, a negative 4 and a negative 4 is a negative 8x, and a positive 16 and a positive 5 is a positive 21. So what this means is that if I was to graph this first equation in vertex form and this second equation we just got in standard form, they should overlap because they are equivalent. So it's just a different way for us to break it up. So looking at this one, let's go ahead and start easy. Start with the vertex. What is the vertex?
Negative 2, 0.
Negative 2, 0. Good. If it's not there, it's a 0. Do you think it's a min or a max? It is a min. Okay. They want us to convert this to standard form. So remember, now we've got this 3 out here. We're not going to do anything with the 3 just yet. Okay. It's not disappearing. We're just going to hold off on it. So if we draw our box, and we have x plus 2 on the outside and x plus 2 on the other side, now we can go ahead and do our multiplying. So x times x is x squared plus 2x plus 2x plus 4, and we have to put our like terms together. And that's where our 3 comes back into play. So we have our 3 outside. And then we're going to simplify our box. So we have x squared, 2x plus 2x is 4x plus 4. So now it looks like what we did way at the beginning of the year with distributing, right? So 3 times x squared is 3x squared. 3 times 4x, 3 times 4 is 12. Don't forget your x. And 3 times 4 is positive 12. And again, if we were to graph both of those in Desmos, they should overlap. So start with the vertex, HK. Insider's leg, what is it? 1, -8. Oh, be careful. Is it a min or a max? It is a max, okay? So when we expand this, remember that negative is going to come into play, just not yet. So if you do your box, x minus 1, x minus 1, x squared minus 1x plus 1. Be careful with those signs. And then we have our negative, -1. Put a 1 there. X squared, a -1x, and a -1x is a -2x plus 1. Don't forget to bring down this -8. Okay? Don't forget that. What does multiplying by a -1 do?
It makes the others negative or a positive.
Just changes all the signs, right? So this becomes a -x squared
Positive 2x.
plus 2x minus 1. Don't forget to bring down that -8. That -8 is not in the parentheses, so don't change that sign. Last step, collect like terms. So we have negative, you could put the 1 if you wanted, x squared plus 2x with a -1 and a -8, -9, and we're done.
Yay.
How could you prove that vertex form and standard form of each function are equivalent? What did we say you could do to check it? Yeah, you should graph it. Graph, and the graph should what? The graph should overlap, absolutely. We've been doing that for a couple units. Vertex form can be used to write quadratic equations when given the vertex and another point on the graph. So remember, the vertex is an HK. It's that special HK. It doesn't have any buddy points versus just a regular XY coordinate. So we're going to talk now about how to write a quadratic function using vertex form, okay? Because it's used for a lot of different things. So to do this, we would plug in our HK and our XY. Remember, this is vertex form. This is on your formula chart. You don't have to memorize it. And we're going to have to solve for A. Remember, A is what tells us how wide or narrow and what direction the parabola opens, okay? Then we can write in vertex form and then standard form if we need to. So the A we talked about before is kind of like slope. It's not slope, but it's like rise and then run both directions. So what happens when we need to find A? Okay, remember we're going to plug this into y equals A parentheses x minus h quantity squared plus k. So they're going to give us the HK. And they're going to give us an XY. So all of our steps on how to solve equations that we've done in the past are going to come into play here. So we need to plug some numbers in. Do we have a Y? Yes, what is it? 2 equals, we're looking for A. Do we have an X?
Yes.
Okay, 0. Do we have an H? -1. Do we have a K? What is it? +1. Don't forget your squared. So now we're just going to solve it like we've done since 7th and 8th grade. So we have 2 equals. Tell me what 0 minus 1 is. -1. Can we square -1? What's -1 squared? -1 times -1 is? +1 plus 1. We need to move all of our constants to the same side, all our regular numbers. How am I going to move this +1 away from my A? We're going to subtract it. So I have 1 equals essentially A, because we're not going to divide by 1. So now we have A. We have a vertex. We have an A. Can we write in vertex form? Yeah, we're going to say y equals. You could put that 1 for the A since we just did all that work to find it. And then you're essentially, you have x minus 1 quantity squared plus 1. You're essentially just rewriting this part and you're putting x instead of whatever the number was. So looking at this one, remember label, right? If it's the vertex, it is the HK. That's the special XY versus just the XY. This one also happens to be a root, a 0, an x-intercept, a solution. That doesn't really make a difference. We do want to write it though, be careful. This one is in standard form. So the one we did a minute ago said in vertex form. So we are gonna have to do the same thing. So y equals, actually not y, we know what y is. We can plug in what for y? 0, good. 0 equals a, parentheses, what's my x? Negative 4 minus, what's my h?
-2.
Negative 2. What happens to a minus minus? Positive 2, quantity squared. And what's my k?
8.
Plus 8. So setting it up is key. So if we need standard form, we're going to have to do the same process. We're going to have to find a, rewrite vertex form, and then take vertex form like we did on the front of our notes and simplify it. So tell me first, what is negative 4 plus 2?
-2.
Negative 2, and we're going to square that. What's negative 2 times negative 2? Positive 4, okay? Move your 8 over. How are we going to move the 8 over?
Subtract 8.
Subtract 8, so we're just solving for a. So essentially, if you like this better, you could write 4a instead of a times 4. What's our last step? Divide. So what is a?
A is 2.
A is 2, negative 2. Okay, and if you don't have enough space for this next piece, you might need to go to the bottom of your notes or write it on the back if you don't have enough space. Because now we got to write it. Y equals negative 2. X, right? Then now we're going back to our HK, right? Plus 2, quantity squared, plus 8. So there's not a ton of space here, so I apologize for that. Again, use the back if you need to. Bless you. So we're going to have negative 2. I'm going to tell you, I know you know how to do the box on this, so I'm just going to go ahead and simplify it for you. X squared plus 4x plus 4. And then bring down that 8. Okay? So what am I doing with this negative 2 now? Yeah, we're going to distribute, but not to the 8, right? So the 8 is not in parentheses. Negative 2x squared minus 8x minus 8. Oh, plus 8. What happens there? They cancel. So my standard form, my ax squared plus bx plus c, is just negative 2x squared minus 8x. You could put the plus 0 if you wanted, but it's not necessary. So now they're giving us the graph, and they're asking us to write in vertex form. And then once you have vertex form, you can change it to standard form. One of the things we're going to talk about, you can pick any of your points here, right? You have to, if you're going to write in vertex form, you have to choose the vertex, which in this case is 3, negative 3. That's going to be your HK. And then pick another coordinate. There's a couple of them listed. You could do, this is 1, 1, or you could do 5, 1. Which one do you want to do here? 5, 1. Okay, so we'll have XY. So when we set this up, let me make sure I can get it all to fit, right? So we have 1 as our Y equals, we don't have A, X is 5, H is 3, so minus 3, quantity squared, K is a negative 3. So remember, 5 minus 3 is 2, 2 squared is what? What's 2 squared? 4, right? Then you can move your 3 over. I kind of ran out of space, so we'll squish it in. It's a negative 3 because our h was originally minus 3. So I end up with, so I have plus 3 and plus 1, so I'm going to write it over here because I ran out of space. So 4 equals 4 times a. So what's a? A is 1. So my vertex form is going to be y equals, you could put the 1 if you wanted. And then remember, this part's just going to stay the same. X minus 3 quantity squared plus 3. Okay, if we needed to change it to standard form, we would do our box, right? X minus 3. Be very careful with your signs here. X minus 3. Oh, I changed color on accident, sorry. X squared minus 3x plus 9. Plus 9. So I have y equals, I don't need to write this 1. My a was 1. It's not going to do anything. So we can just write x squared, negative 3x, and a negative 3x is a negative 6x plus 9. But don't forget this plus 3. And then you're just going to collect like terms. X squared minus 6x plus 12. And again, when you graph both of those, they should overlap. Hold on a minute. Oh, I wrote this wrong. Nobody caught it. Go back. This, look at our k, minus 3. I wrote minus 3 up here, but I didn't write the minus 3 here. So that's actually going to change this. I apologize. So this should be a 6. Signs matter, right?
Mm-hmm.
So when I rewrote it, I didn't catch it here. So be careful with your signs. Mr. Turner graphs the function g of x and h of x on the same grid. G of x has a vertex of 210 and passes through 0, 2. Function h of x equals negative x minus 4 quantity squared plus 8. Which which function has a greater max? Guys, the max is just the y value. That's all we're looking at when we talk about max and min. We're just looking at the y value. So if the vertex on g of x is 10, so then g of x, the max value is 10. It's the k on the hk. What's the max value on h of x? Max is 8. So which one has a greater maximum? There you go, g of x. So don't overthink it. When we talk about mins and maxes, we're talking about the k on the hk, the y value of the vertex. All right, consider this. Mark the statement true or false. If it's false, correct it. So if you wanted to graph this in your calculator in Desmos, you could. I'm going to tell me the vertex right here. Here's my h and my k. What do we have to remember? Insiders lie. What is my vertex? Negative 7, negative 9. So is this first one true or false? It is false because it should be a negative because insiders lie. If I was to make a graph of that, negative 7, negative 9 would be right here. Look at your A. Is that a min or a max? Is it opening up? Is it opening down? It is opening down. So, knowing that, is the range y is less than or equal to negative 9? Yes, because it's at the top. So this one is true. All right, is it equivalent? Now you're going to have to do your box again, okay? So you have your x, you're going to have to expand it. X plus 7, x plus 7, 7x, 49. So I have negative 2 times the quantity of x squared plus 14x plus 49, such giant numbers. And then don't forget the what? Don't forget the minus 9. Distribute If it helps you to use notebook paper to do this, you might want to do that as well. So this is minus 98 minus 9. When we put these together, you can tell that this is, yeah, 2 times 49 is 98. So then we get, so this is not correct because it should be a negative 2x squared minus 28x minus 107. That's what it should be when you simplify it.